Good morning, gentlemen. I am going to discuss in this presentation, which is in form of a webinar. I will discuss silicones, and I will try to cover the manufacturing, products, markets, as well as the Saudi potential of this business. These are some examples of silicones. Silicones includes sealants, adhesives, resins, elastomers, plastics, cosmetics, lotions, and large number of products. And there are more than 7,000 products of silicones which are available in the market. The whole story starts from the quartz mining. Quartz is converted into silicon metal. Silicon metal is converted into some chemicals, and from those chemicals, the basic chemicals, which is siloxanes, is produced, and from siloxanes, more than 7,000 products of silicones are produced. Before we go to the discussions on silicones, I would like to highlight the products which are produced from quartz, the other products which are also produced from quartz. So there are two main products produced from quartz. Number one, high purity quartz. Number two, silicon metal. These are the two main products. High purity quartz, when the high purity quartz is produced from quartz, there is no chemical change. There is no change in the chemistry. What we do, we just remove the impurities by intensive processing, and an ordinary quartz which has 99% silica, 99% purity, it is changed into more than 99.99% silica. But the processing is very intensive. The world demand of high purity quartz is not much. It is hardly 60,000 tons per year. And there is a monopoly of 3 world producers, and the leading producer is Unimin of North Carolina, belongs to Silicone Group. Price of the high purity quartz ranges between $6,000 to $15,000. It all depends what are the impurities left, what is the percentage of impurities, what is the intended product of high purity quartz. There are many products produced from high purity quartz. The most important is the crucibles, high purity quartz crucibles, and these crucibles are used to convert monocrystalline silicon to convert polysilicon into monocrystalline silicon for photovoltaic, solar, and semiconductors. High purity quartz is also used to produce optic fibers, high temperature lamp tubing, high performance lenses, and many other applications. On the other hand, when we convert quartz into silicon, there is a change in chemistry. You can see silica quartz is changed into Si silicon. And the silicon metal is used to produce aluminum alloys. It is used to produce trichlorosilane. Trichlorosilane is a basic material to produce solar and semiconductor grade silicon. Solar silicon is 99.999% pure, and semiconductor grade silicon is 99.9999999%, that is 99s silicon. Silicon metal also produces silicon tetrachloride, a chemical, and this chemical is used to produce fumed silica. Fumed silica is a very fine, fluffy, very fine grained silica used as a filler in certain applications. Also, silicon metal produces another chemical which is called dimethyl dichlorosilane, and this is the basic chemical that produces siloxanes and silicones, and this is going to be our topic today. As I told you, the fumed silica that is produced from silicon tetrachloride is used as a filler in the silicone products. Let's see how this whole value chain works. So quartz, after upgrading, it changed into high purity quartz that can produce quartz glass and a large number of products. Quartz can also be upgraded into medium purity quartz, and medium purity quartz is used to produce EMC fillers, that is epoxy molded compound fillers for electronics. Medium purity quartz also used to produce engineered quartz stones. It is also used to produce solar silicon by direct reduction method, but it is not commercialized yet on a large scale. Quartz produces silicon metal by the reduction process, and silicon metal is produced trichlorosilane for polysilicon. On the other hand, silicon metal can also produce silicon tetrachloride for fumed silica, but as our main topic is, silicon metal produces dimethyl dichlorosilane to produce silicones. I already told you that fumed silica is used as a filler in silicones. Silicon metal is also used as aluminum in the aluminum alloys. Let us see what materials are needed and how much is the investment from quartz to silicones via silicon metal and silane. The whole story started from the quartz mining. When the quartz is mined, quartz is converted into silicon metal by reduction process, by removing oxygen from quartz. This whole process takes about US $350 million total investment. Production, by the way, a greenfield silicon manufacturing plant produces 30,000 ton silicon per year, and to produce 30,000 ton silicon we need 90,000 ton quartz, and that much investment, for sure you should have enough raw material for next 20 years. For 20 years we need about 1.8 million ton quartz. Also, beside, we need the production facility to produce methanol. In Saudi Arabia, SABIC is producing methanol, but the investor can also produce its own methanol. Methanol and hydrochloric acid, they produce methyl chloride. Once again, the investor can produce its own methyl chloride, or that can be purchased from SABIC. Methyl chloride plus silicon metal produces the basic chemicals dimethyl dichlorosilane, and when the dimethyl dichlorosilane is mixed with water, hydrolysis, it produces siloxane. Siloxane is the basic building block for producing a large number of silicone products. On the other hand, we also produce silicone fluids. Silicone fluids also used in a number of commercial applications. So silicones are the finished products. From silicon metal to siloxane, the total investment is about $1.1 billion. Let us conclude. What are the silicones? Silicones, the term silicone is used for a group of more than 7,000 commercial products, ranging from elastomers, rubbers, plastics, resins, waterproofing material, weatherproofing material, chemicals, coatings, cosmetics, lotions. It's US $15 billion per year sale, 25,000 customers, and more than 7,000 products. And this is highly diversified market. Who are the main players of silicone? Dow Corning is the leader with a 38% share in silicone business. Momentive with 18% share. Wacker 17%. Shin-Etsu 10%. And then there are smaller one, Blue Star, Evonik, and others. What are silicones? In terms of chemistry, silicones is a generic name for a variety of polymeric chains and network construction around repeating backbone of silicon, oxygen, silicon. I'm not going to discuss it in detail, but you remember that silicones are based on a chain structure of where there is a silicon, oxygen, silicon, and this chain can attach a large number of methyl molecules together, and that forms large number of products. The final products include elastomers, rubber, sealants, adhesives for construction, transportation, aerospace, textile, household, electronics, healthcare, food, and feed. The total this sales of silicone is about $15 billion per year. And there are many different kind of silicones. There are elastomers, which are rubber and sealants. The market is construction, transportation, adhesive, sealant, aerospace. Then there is another kind of silicones, standard silicones, fluids, which are used in textile. You have seen the jeans, they are coated with, and jeans and some textiles, they are coated with the silicone fluids. Household, personal care, lotions, creams, hair care, electronics, paper, food, feed. And there are specialty silicones. Chlorosilane. Chlorosilane is a general name given to the reactive chlorine chain compounds. The most common chlorosilanes are dimethyl dichlorosilane. It is the primary building block of silicone production, also known as monomers. Chlorosilane, there is another type of chlorosilane, that is trichlorosilane, which I told you that trichlorosilane is used to produce polysilicon, either for solar, photovoltaic or semiconductors. There have been so many Saudi projects since in last 15 years to produce silicon metal, polysilicon for solar applications, but none of them was successful. Presently, in last few years, there was a company working on making polysilicon. The name of the company was Polysilicon Technology, but there was something wrong in the design and that production is also stopped. Basically, the structure of dimethyl dichlorosilane, you can see one silicon attached with 2 chlorine and 2 methyl, so we call it dimethyl dichlorosilane. Trichlorosilane, there are 3 chlorine atoms attached with the silicon and 1 hydrogen atom. What are siloxanes? Siloxane, we say that these are the basic building blocks. They are starting point for variety of silicon products. They are produced by adding water to dimethyl dichlorosilane. From hydrolysate to finished product, once again, I am not going to discuss too much chemistry, but I tell you that there are siloxanes are produced and silicon fluids are produced, and both are used in different kind of silicon products. This figure shows the value chain. The whole process starts from the production of methanol plus hydrochloric acid, and mixing them we produce methyl chloride. Then methyl chloride plus silicon metal produces methyl chlorosilane, that is dimethyl dichlorosilane. Hydrolysis of dimethyl dichlorosilane produces hydrolysate, or what we call siloxane, the basic building blocks of silicones. Process, there are so many processes: equilibration, condensation, hydrolysis, emulsifying, compounding, distillation, etc., etc. Then we produce silicones. There are, as I told you, we can classify silicones into 3 groups: elastomers, rubber sealants, standard silicone fluids, specialty silicones. Elastomer, which is rubbers and sealants, they are for the market, construction market, transportation, adhesive, sealant, aerospace. Standard silicone fluids for textile, household, personal care, electronics, paper, food, healthcare. So, once again, methyl chloride, which is produced from methanol and hydrochloric acid. Then we need methyl chlorosilane, which is produced from silicon metal plus methyl chloride. Then we produce siloxane from dimethyl dichlorosilane plus water. So, siloxane is the basic building block. Is already discussed. Now let's see the global players. What are the global players? Who are the producers and who are the buyers? Input: silicon metal, organic chemicals, and energy. These are the three things. Primary silicon producers: Dow Corning, Momentive, Wacker, Shin-Etsu, Blue Star. Customers: consumers: L'Oreal, Turtle Wax, Procter Gamble, Kimberly Clark. Durables: Michelin, the tire producer, Michelin, DuPont, Goodyear, Delphi. Industrial producer: BASF, Dow, Owen, Corning, glass manufacturers. Nalco. Electronics manufacturers: Motorola, Canon, Sony, Toshiba. Markets: construction, transportation, adhesive, sealant, aerospace, textile, household, personal care, electronics, oil and gas, paper, food, and healthcare. Saudi potential for silicons. Estimated total silicon demand in Saudi Arabia is 240-250 tons per year. Total silicon metal needed 63,000 ton per year. Quartz required to produce 60,000 ton silicon is 190,000 ton. Greenfield silicon manufacturing capacity is 30,000 ton per year. Quartz resource is needed for 20 years, 3.8 million ton. Then we need the production facility for methyl chlorine, and we need 200,000 ton per year. Methyl chlorosilane 260,000 ton per year. Siloxane manufacture 130,000 ton per year. Total investment here is 7.6 billion ton, and it does not include the quartz mining and the production of silicon. It is when we already have silicon. Silicon metal production cost $350 million is not included here. Estimated investment: basic siloxane manufacturing facility that is 100% owned by Saudi needs $750 million, or 50% Saudi owned basic siloxane facility and equity interest in new global silicon production and market, joint venture shared minus 750 million investment. Quartz mining $150 million, silicon metal production $350 million. Conclusion: establishing an integrated siloxane facility, methyl chloride, dimethyl chlorosilane, and siloxane, it will cost 750 million. Quartz mining operation, that is 150 million, and silicon manufacture 30,000 ton per year is equal to 350 million. Possibility of integrating quartz mining and silicon metal production should be investigated properly. The siloxane facility will facilitate establishment of downstream silicon process in the country and products of global demand and joint venture technology partners business requirements. Thank you very much.